My name is Sarah Hu. Other instructors here are Jacob Cram and Philip Leftwich, and we're going to be we're going to continue talking about data wrangling if you're keeping up with the lessons, and go over some more plotting information. Can you guys see our studio good as well? Yes. Cool. Like we did with data wrangling, I asked people in the R channel if they had any things that they wanted to learn with respect to plotting, and I tackled a lot of those things. If you have this open, make sure that all these can be executed. So if you start up and you don't see anything, you just come over to Files and start up. The R script is listed here. I'm going to just change some of these options in here so I can soft wrap. Okay. So, we need the plotting space.
What did you just do?
What do you mean?
What's soft wrap?
It's so like when things are so that like all the code is here, it doesn't like disappear.
Oh, clever. Okay.
I don't know.
So that's cool.
If you don't mind executing these lines to make sure your libraries are loaded, if you have to install them, it might take a second. So go ahead and do that now. And I want to talk about a couple things that were brought up in the channel. I know someone asked about heat maps this morning, so that's not addressed in this at all. But I think I'm going to respond with a couple of packages that I use for making heat maps. And then if others have comments, please chime in and maybe we'll address them later. And then someone asked about network analysis. There's a network analysis channel. So we'll, I think, Jacob, can you actually provide an update on where network analysis is right now?
Yeah, we're talking about time series networks this week. Yeah, we'll be talking about essentially how to do make a network that looks at time lags in R.
You mean ELSA?
Nope, not yet. That's next week.
Cool.
So ELSA is a popular tool to make networks, but one of the points that I was trying to make is that you don't need it, and you can actually just run a lot of this stuff as a standard R script. For a lot of the networks that people use ELSA for. So the L and local similarity analysis is for local, and a lot of times people just want a local essentially means a relationship that happens over one part of the time series, but not the whole thing. And sometimes you want to look at associations that happen over the whole time series. And ELSA can do that, but you sometimes don't need it to. So.
Okay. No. And then someone asked about the PCOAs, and I think we're going to start moving into I don't know, Philip, maybe you have another idea on it, but we're going to be doing some stats and continued plotting and data wrangling, but all at the same time, because a lot of those are intertwined, and it's important to talk about stats when we talk about this stuff, because it feels irresponsible to just tell you what the command is for PCOA without talking about it. That's my opinion. And so we'll go over that briefly a little bit today, but we'll focus on PCOA in the future. And I have a tutorial that goes over it, and so maybe I can tackle that. Another question was about a single chart with two y-axes. So this is a 100% no in the tidyverse for some reason. I mean, I understand why, I guess, but if you were to Google ggplot two axes, there's people fighting on Stack Overflow of no, you can never put two axes on one plot. You can do it in base R, because if you recall from last week, Ella talking about base R, and you build up the plots, you can just add two plots on top of each other basically. I personally don't usually do that. I'm not fighting on Stack Overflow personally either, but maybe we can cover that later. Maybe we'll have a fight about it on our Slack channel. It sounds fun.
I'm in.
What?
I'm in. Let's do it.
Okay.
Slack.
So we'll talk about, I'll send some packages about heat maps, but maybe we can address that later. And then I'll mention something about heat maps while we're talking today. So first we're going to tackle bar charts versus box plots, and I'm going to show you how to plot both of them. And today we're using, and I'm doing some coding as we go along, so make sure you have everything enabled and ready to go, because I'm going to add a lot of code to this. So the first thing we're looking at today is the Star Wars data set. I did not make this data set. this is actually, I think it's from the tidyverse. I might be wrong. But when you go and look at some of the examples in tidyverse, it uses the Star Wars data set to show you how to like group things. And so, right, each row in this is a character from Star Wars and different traits from that character, right? Height and mass, which we'll talk about today, and other traits, homeworld, species, and then the films that they, and other things. So I thought it would be a fun data set to use today. The first thing that we're gonna focus on with bar charts and box plots today is we're just gonna narrow it down to one of the home worlds in Star Wars. And so, right, this line, remember that from the tidyverse is filtering, so it's selecting only the rows that are from Tatooine, or the characters. And so the first question I have here is, right after I subset that, I'm still trying to understand like what's going on in this data set. And so I do a lot of how many species are in Tatooine. So I usually go and pull up the number of species. There's 2 that we're going to be looking at today. If I want to know just the total number, like say there's too many to count here, I can use these things in base R that just kind of give me like basic stats if I have those specific questions. And we've gone over some of those. Philip went over those with Scam, I think does some of that stuff. Summary does. Okay, so one thing that I wanna look at is looking at species, height, and mass on Tatooine. And so this is the ggplot. Quick review of that, right? This is the ggplot command. You're first putting in the data, and then in this aesthetics, you're designating what the X and Y axes are. And so I want to make a bar plot in this case, because now I have genome bar here, that is going to show on the x-axis species and on the y-axis height. So by executing that, I have, this is my basic bar plot. And this is where I definitely invite people to chime in on interpretation, or if they want to see something different here. One thing is that this is not maybe the best way to demonstrate this, the height and mass of these different species on Tatooine. And I think a better way would be a box plot. And I think all of us probably know what a box plot looks like. But when we think about the mean and the median of some of this data, those aren't necessarily aligned. And right within the droids and the humans, there might be a distribution of weights and a distribution of masses that we want to know. And so there's ways that we can start to diagnose this. And I'm going to try to do that using tidyverse and like plotting different things or pulling out the mean and the median. And so let's see. I'm going to start from the Star Wars data set. Actually, we can start with Tatooine. So do you guys remember how we were calculating the mean and median for some of these things? No? I know, it's okay, I'll do it. So first, we need to do a group by, because in Tatooine, I want to understand what's going on by species and homeworld. I think we've already filtered by Tatooine, so I don't need to include homeworld here. But if I was starting with Star Wars, I could put the filter command here. And then in summarize, we want to calculate the mean, and that we can simply put it with height. And in this case, I actually need to add mean height here. I also want the mean mass. Oops. And then I want to do the same thing for median. And I have a habit of putting all of my new values in column names in all caps for some reason. I don't know when I started doing that. That's just a personal reflection. So this is how we calculate those medians. And this has to be mass. So now what I get printed out here is by species, I now have the things that I calculated. And actually, we're getting NAs here. And that makes sense because I think when we count up, which, right, so now I want to know like how many individual species actually exist. And then this is the notation for that. It's like looking for the total number. It's like unique, how many species are listed when I do this group by species. And so now when I do this, I actually see that the droids only have 2, and there's only 8 different human characters on Tatooine, I guess. So this is kind of a small data set to work with, but we will go with it. And try to prove to you why this data is better represented in box plot instead of bar plot. Anything to add, Philip or Jacob, in this moment that would be helpful in determining, like, kind of trying to learn what the Star Wars what's in the Star Wars data set before we move on to actually showing a box plot?
I have a question. I'm a little puzzled why I can't find a median of 2 points. Because if I just run the median thing and put two numbers in there, I get a median.
Really?
Yeah. So if you do like median of like 2, 3.
So it's not the 2 droids that it can't calculate the mean from.
What's the 8 humans?
It's the humans, and it's because there are 2 humans that have NA values in their mass.
Oh.
So if you remember the previous lesson, this is where NAs screw stuff up if you haven't checked and filtered them.
Mm-hmm. Is there a way? Oh yeah, we've already gone over that. Okay. So that would be like viewing Tatooine here.
Yep.
Yeah, and then we see that there's some NAs because we don't know the mass of their characters.
Okay. So let's fix that. Let's get them. But let's figure out what the mean is of the characters who we do have masses for.
By removing the NAs.
Sure.
Okay, so then we do filter, and then we know that it's mass is a problem, and so we want to remove his NA from mass. Yes.
Cool.
That's how we do it. Thank you for the phone challenge. Okay.
Yeah, so, I'll throw in that you can do that up at the filtering command. You can also do it down in the summarize, right? So you could do like mean is NA height, if you wanted to. But I think the way Sarah has it is much more conservative.
You mean you could put it here?
Well, we can just nest inside of mean, right? You do mean parenthesis is NA parenthesis mass, and then 2 and but the way you have it is less typing, so your way is better.
I know. Okay, so so this is right. Like I said, this bar plot is maybe not the plot that we're looking for, and so let's look at this. So instead of before, I'll just scroll up here. We had a geom bar, and down here we can just change it to geom box plot. And I'm getting an error for some reason. What happened? Okay. Okay. So I think that this was trying to plot only human. So I'll build on this box plot and kind of show you where the data actually falls throughout here. But recall, I say recall because I assume that everyone's kind of seen a box plot before, but the median is this middle line here. We have the upper and lower hinges that represent the 25th and 75th percentiles, and then the whiskers show like the extent of the largest and lowest value, but within a range. And so outliers are usually data points that do appear in here automatically. And I do want to make a note that in base R box plot, they're actually different than in ggplot. And so this is an example of making sure we're responsibly showing you code. So if you do box plots in base R or ggplot, just make sure you always look it up because sometimes there's different interpretations.
I just throw there that your box plot of droids has 2 data points in it, right? So we've made a lot of box out of 2 points.
Yes, it did. We could change this. So, well, we're not going to change it right now. we're going to just go with this and we're going to focus on the plotting, and then maybe we'll circle back and look at what happens when we just subset all droids and humans out of all the home worlds and not just then on one planet. Okay.
So your box plot that you're showing right now with your medians and your interquartile ranges as a comparison to the bar that you produced like a couple of minutes ago, the bar was just sort of way off, right? Because it basically just totaled everything.
Yes.
And presented it as a so obviously the other way that you could do it with the stuff that you've just you've built in terms of your mean as a new data frame, you could choose to make a bar chart that now displays your mean, couldn't you?
Yes, you can. Meaning within the box plot code, just change it so this line is actually the mean.
Your box plot code, or just if you wanted to do bars with standard errors as you would normally produce, it's like the box plot's done a lot of the hard work for you in that it's summarized the data in the way that the bar function that we just do, it wasn't smart. It just sort of tallied everything rather than producing you a nice summary data.
Yeah, exactly. And so this would be what Philip was talking about adding the standard error, right?
Yeah, mean and standard error if you wanted to produce your sort of classic bar chart.
And I'll do this for mass only, right? Yeah, I'll do it for height for now. So we want the standard deviation of height divided by the square root. Is that how square root? Yeah.
You want to get square root of n.
N. And then yes. Is it n height though? No, it's group.
Nope, just n.
But no, I think you're right, Sarah. I think it's n of. Is n by itself a thing?
What I would actually
you have to
open close parenthesis.
What I would normally do is actually do this, where I have the standard deviation of height elsewhere, because I maybe want to look at that value as well.
Mm-hmm.
And then I would recall I'm using summarize and mutate in this function, and so summarize will give you a new table with all new rows that you've specified based on the group by statement up here, whereas mutate is just adding columns. And so if summarize this right here, I'm creating a new table with all those values which I printed out previously. But now by adding mutate, I'm just adding more columns. And so mutate statements often follows summarize for me because I've created new things and I want to add even more calculations in math. So that's what's happening here. So standard error, and then I always convert things to data frames. I'm going to set this statement equal to something. And then, what did I do?
And still a problem. It doesn't know what that means.
This is count, right?
Yep.
Mm-hmm. Yep.
Okay, so now we have height temp. So see, I've added that additional column for standard error. And we're only going to, I think I needed to add standard error for height and mass individually because I did not group by those variables ahead of time based on how this data frame is set up. But I'll actually get to an example of that later. So then to actually plot this and what Philip was talking about, ggplot, we'll do height temp, and x is going to be equal to species again. My y will be equal to height. I'm going to do geom bar.
It's going to be what are you picking? Mean height.
Oh, that's right. Mean height. Stat is equal to identity here, which is like a necessary thing for when you're doing a geom bar. And then I actually want to add error bar. So now I'm going to show you how to do that, which is geom error bar. And then in here, you have to specify an aesthetic because it's taking data from your data frame, similar to how you add an aesthetic in the first part of the plot, or you can also add this to the geom bar component, where we want to specify the on the y-axis an error bar, right? And so the y min will now equal the mean height minus the standard error. And then I'll repeat that with y max, and that I'm going to make that equal to mean height plus the standard error. So now I have error bars, and they always, for some reason, default to being extremely ugly, I think. So there. So that's like outside of this aesthetic statement. Oh, I put that inside for some reason. This doesn't need to be inside. It needs to be outside. It's better that way. So this aesthetic statement now has the y min and y max to define the error bar range, and then this width is just the width going the horizontal bar part of the error bar, right? That's what you're talking about, right, Philip?
Yeah. And it's so much code compared to box plot.
What happens if you take the stat identity part out?
We're gonna get to that.
Okay.
But not right now.
That's good.
Okay. So let's go over box plot, and then we'll come back. So I'm gonna add a bunch of plots together, right? So recall how we had humans and droids, and we had, I think it was like only 8 humans and then 2 droids or something. Maybe I have that reversed. We want to know that value as well when we try to summarize the species on Tatooine. And so I'll include that information in a second using a bar plot maybe. So right now, let's focus on the box plot for another second. So this is what we were looking at, right? It shows, I think, a better representation of the distribution of both let's see. So the better distribution of the heights of both of these species.
Well, this is an interesting point, right? Because so the mean and the medians were pretty much identical between these two data sets, and they're often not, but they were pretty good here. But your box plot is giving you more information about distribution of your data set, whereas a mean with a standard error is by definition supposed to be essentially a summary statistic.
Yeah.
So one is a descriptor, and one is a kind of getting towards making primitive statistical models, right?
Mm-hmm. Yeah, and so I've been making as just a personal example, and maybe other people can chime in with other data that they think a box plot would be better for. But I've been plotting like temperature values, and I have like 3 different temperatures taken, and they vary a little bit, but they represent like replicates, and I want to kind of show an average of that. But I also want to make sure I report that there was a little bit of a distribution of temperatures, and so a box plot's going to be a better way for me to report that value. Anything else? Any questions? I haven't been able to look at the chat if there's a question.
Just are we going to have all the code later?
Oh, yes.
Yeah.
I'll save this and upload another version. So so we're working with these plots. I'm using these arrows to toggle between the previous plots I've made. But another thing that I usually add to box plots is the actual data points. And so this actually shows that the droid values, there's only 2 data points even shown, whereas the humans, there's many more. And you can imagine, I'm sure you all work with like a lot more data than this, where these data points can get kind of complicated. And so I just want to show you what genome jitter looks like, which is like just distributing those data points a little bit more. So I encourage you to like check out ggplot, box plot options, or ggplot other things you can add to these. There's like violin plots, notched plots. I actually have some code here for that I commented out. So actually you can add this statement to the genome box plot, and we'll add in red and green here. And so I don't know what's happening with that notch. I'm gonna remove that. I'm so sorry. So usually if you have more data, maybe it makes sense, but the notch kind of shows I think you can offset that to be the median or mean. Yeah, so I just removed that for now. But what's happening here is that this is why I really wanted to show you like how I approach making plots. And so by doing this code during this class, I think is kind of fun, but there's going to be some errors. So this width is just showing the width of the box plot, and then fill, there's a difference between fill and color in ggplot, where fill is in the inside and the color is actually the outside border. But if we remove, I think if we remove fill completely, there might be automatically it fills with white. And so that's ways that we can add color to these plots.
What does varWidth do?
It changes. It changes the width. I'm sorry, it changes the width of the box plot based on how many data points you have. So the droid one is really skinny because we only have 2, and then humans it's wider.
Got it.
I think that's. I wonder if we can. I'm going to repeat this with mass. Okay. Recall we're using the Tatooine data set. X equals species and Y equals height. And we're just gonna try this because I don't usually make these. Yeah. So the violin plot is another way to distribute all of this is a terrible way to show the violin plot. But check it out. It's suitable in some cases, I promise. Right, so in the human one, we had all these data points, and the violin plot, like the outside edges of it kind of correspond to the weight of that value, right? So it'd be wider if there is a height of like several data points compared to another one. And recall with mass, we have fewer data points.
The violin plot is basically a histogram.
Yes.
It's just a histogram kind of turned vertically and stuck on in a bunch of rows.
Mm-hmm. All right, and so one thing I want to mention is that when I do recall, we had the NAs in the mass data set, and so ggplot actually gives you a warning message because it had something that it didn't recognize or had an error message. That's what's happening with that. So I want to, let's see, what's going on here. So now I want to return back. So I talked about box plots. We're actually going to go back to those box plots, and I'm going to replot them in a different way, just to kind of show you additional data wrangling with a ggplot. But here is what Jacob was talking about with changing stat. And so in this geom bar, the only thing that's different from before is now I don't have a y value. And I have geom bar. Instead of it equals identity, it equals count. And so what's happening is that it's actually counting up how many species are in the parameter, the X parameter that I've defined. And so this is how, recall we were also finding out how many species of droids and how many species of humans there were. This is how I can show that information. And this makes sense in a box plot because I just want to know the total number. And so here I wanted to show a couple of examples of how to like dress up some of these plots. I like to think of ggplot as very like a la carte. And so this is a very, this is one line of code. I've just broken it up onto 2 lines. But if we start adding some aesthetics, we get a whole nother plot. And so I've set this, so that's the plot, and I'll break down what I'm showing, and I'll change a couple of the parameters. And please let me know if you have in a question if you want to see a feature of this plot change, and I'll try to do it during this lesson. So this is the base plot that we had before, right? X was equal to species. We have stat equals count because we're looking just for the total number. I've changed the width of the bar to be 0.4. I think the standard is 1. So I'll change this to 0.2 to see how that changes. Again, we have color and fill defined. And so color is this outside line, and then fill is orange. And you can imagine if you start adding on a lot of colors, you might want to have, or adding on a lot of fill colors, then you might want to have a color on the outline layer to differentiate the different boxes. I probably spent a lot of time looking at ggplot themes, which are really interesting. I think this is the one that I usually default to, but we can, there's one that's called minimal. You can Google these, a lot of them are available. You can even download themes like that are from The Economist, or I think there's like a 538 one, and you can download the themes that they use and then use the 538 theme, and then all your plots will look like they're from 538. And then this labs line is defining the X and Y parameters. You can also add a title here. Species count on Tatooine, right? So I have like X equals and Y equals. And then this is the here, I'll X this out for now and look at this plot. Oops. So what I've done is I've removed this last line here that is a theme, which I'll go over what's going on in there. But by changing those little things, this minimal got the theme minimal got rid of the axis lines. It's very minimal. And I have now like a plot title, and the width of these bars got even smaller. Now inside theme, I'll kind of break down what's happening in here, but this allows you to change pretty much every other part of the plot. For instance, what's happening here is that I wanted to change what's going on the x-axis. So this is the droid and human variables. I'm actually going to just delete this and retype it out. So when you start typing axis, a lot of options come up, and another reason why RStudio is great to work with. And these are all the things you can define, and I'll actually define axis text because then it will apply to both the y and x axes. But previously I had .x here, so I'll just play around with this for now. And then that's set equal to something. And if one option is always to do element blank, followed by another parentheses inside theme. And by doing element blank, you actually remove all those variables. So there's something that you're trying to remove. The ggplot syntax for that is setting it equal to element blank. But normally what you want to do is probably set element text, where you want to actually modify the text in here. And it actually defaults to to gray. And so I can change this to red, for instance. I can change the size of that text to, we'll make it really big. And then I can change the angle of that text if you have a plot with like long sample names or something and you want to change the angle. So so now I've changed both the X and Y axes to be red and at a 45-degree angle for some reason. This is not how my plots normally look, I promise. Okay. That's what they look like. No. This is I just wanted to show you like the examples of how, like, I think some of my ggplots the code for them gets super long, but really like the code part of them is really just right up here where I'm just defining the variables. And so I want to kind of show you what that looks like and how you can start building upon it. And it's really easy to Google all of these things. Any questions right now before I move on to the next concept? So one thing, I mentioned this at one point where I prefer to put pretty much everything in long format first. Jacob and Philip, do you have any comments on that?
Long format as opposed to wide format?
Yeah.
Yeah, me too.
Okay.
And that's just because it allows you to do stuff you can't do otherwise. Like,
yeah. So I'm going to show you an example of that right now. And kind of why it's, recall how we actually plotted the height and mass separately. We had to like make two different plots for that. By putting it in long format, you can actually just do that at once. And so I'm going to show you an example of how to get to that space. Reminder, we're starting again with the Star Wars dataset and base. And then this is a big tidyverse statement that we've gone over similar things in the past, but I'll walk you through it again, where you're starting with the Star Wars data set. I had to print out call names here. These are all the columns that we have. We talked about some of these previously. the first thing that this code is doing is selecting all the columns that I just of interest that I want to look at right now. The name of the character, height and mass, homeworld, and then its species. And then again, I'm filtering by Tatooine. And then here's the pivot longer statement where in this, actually, how about I just break this down really quickly. So I will execute, I'll repair that in a second. So if I just execute that, oh no, I did this wrong.
Just
Okay.
highlight it.
What?
Just highlight everything from 111 through 113.
Oh, that's right.
Run
Okay.
that.
So when I do that, and then it prints out, I always forget to do that. Okay. It prints out the data frame of me just selecting the columns that I want and then just Tatooine. Okay. And so what I want to do is the next step is actually pivot to longer. And to pivot longer, I want to select the 2 columns that I want to basically collapse into row format. And so I'm selecting, and again, remember we can always do pivot. Oh my God, I always do that. Pivot longer to kind of, I have to do this all the time to like remember what all these values are. So the columns are defining the columns that I want to collapse, which in this case, I want to collapse height and mass. When I collapse those, I want to call them measurement with the new column name. And so those names, that new column that lists height or mass will be called measurement, and the values that are report the height and mass, that is going to be a new column called value. So to show you what that means is that at the end, this is what the long version of those look like, right? Where we have, again, the character name, the homeworld, species, and then the height and mass, right? So in this case, where Luke Skywalker is technically listed twice, but it's because we're trying to separate height and mass here. And so to show you why I always default to using long format is now we can actually plot both of those measurements. So this is where I will plot that. So in ggplot, we're going to, again, we're start with the data frame that we want to draw from. The aesthetics are going to be determined by x equals species. And then in this case, instead of having to decide between height and mass, for instance, I can actually just put in measurement directly. Nope, that's wrong. It's value, because we're going to make an x and y plot, and then the y plot will have the value. And then geom_bar, again, we want to report the actual identity of those values, not just count them up. So we put that in. And then this is where now we can add an additional aesthetic in my bar plot where I want the fill, so the color, to equate to measurement. So then let me see. Let's look at what this is. Okay, so now I have measurement of height and mass, and they're mixed on one value here. And I get that error message. Recall that's just because we have those NAs. I'm going to ignore that for now. So to separate them, I'm going to use a grid where I use
Facet wrap.
What?
Facet wrap.
Yes, or wrap.
I guess grid will work. Okay, yeah.
We can look at both. And so in this case, I actually want to designate measurement in this case. So what did I do wrong? Oh wait.
So a squiggly line before the measurement. Oh.
Yeah, so you can do a squiggly line before or after. So I'll go over that. And so now, right, this is what I want. I want height and mass of each of the species reported. And I definitely did not use a box plot like I talked about for so long. Oh no, what did I do?
GM box that identity, does that confuse it?
Yes. So remember how I was talking about how box plots are better than bar plots? Yeah. So, okay, so now I've done facet grid and right, so the box plots for height versus mass are separated. They're separated and they're separated this way, but now, like Jacob said, if I had put in this tilde and period here in front, then it would have been going the other way. All right, and so I usually have to pull up or play with, do a little trial and error with my plot and facet grid facet grid to figure out which direction I want the plot to go. And this, you can actually put in two variables here. In our data frame, we don't have another home world here, but if I was going to, I wonder if I can just, I'll add homeworld here, for instance. So now Tatooine is on this axis, or listed right here, right? And so if I had additional homeworlds listed, then it would start building on this grid, and then I can show all the heights and mass for the various species. So I put some colors here, or some things to do here, where I decided to challenge myself in real time and add these things. So let's do that. Okay, I'm gonna start up here. So let's add a theme. I'll add the theme black and white. We can add X and Y labels, X equals species, and then Y equals, I'm going to just continue using value. And then another thing is that I want to add different colors. And so I'm going to show you how I actually set those colors. So we're going to do species order. And right now it's listing droid and human, usually goes in alphabetical order. A lot of people want to switch that. And so I'll actually switch it to human and then droid. And then I want to add a color. Green, and then I'll use black here. And what's going to happen is I will factor this. And so in my Star Wars data set, I'm going to add, and Jacob and Philip, if you have another way of doing this, this is usually how I factor things. But I think that there's more than one way to do this. So I'm going to do species order, set this equal to a factor. And in that factor, I'm going to do Star Wars long species. And then I set the levels equal to species order.
Yeah, the other thing I do different is I do that with called the mutate.
Mutate?
Right. So you do Star Wars long, and then pipe. So you save the Star Wars long, you do Star Wars long, pipe that to mutate, and then you'd have basically the whole factor call that you have.
Oh, I see. Yeah,
just to get rid of the $sign.
Okay. Yeah, when we make the final code, maybe add that in as another example then. But I think I write it out this way because one of the things I do next is actually add color, and I set this equal to species order. And then this makes sure all those colors that are listed here will always go with those names when I add those colors in. So green will always be human and black will always be droid, even if I was to continue plotting this. Obviously, what typically happens is that I have way too many things I'm trying to plot, and I'm trying to decide on colors for over 12 things, and then I have to keep all of that straight. So you can imagine why it's nice to kind of have these lists separate. And so by assigning this, I just executed all those lines. Now, when I look at Star Wars long, I have a new column that I've added, and it's called species order. And it's the exact same thing, but encoded in it is the order that we want, because it's a factor. And so now in my GG plot, I actually need to change the x-axis to be this new column that I've created. And that is telling ggplot that I want it to be in that order. And because I have colors assigned, now I can do this scale fill manual, where I can set the values equal to species, the right color. Oh, it did not work. What did I do? Oh. What did I do wrong? Nope. Let's see. I actually don't want this, right? I want value, and then oh yeah. Okay. So what I did was instead of having, so measurement was currently the color, but I actually wanted species. So I'll go back to what I was doing. So in fill, I previously had this as measurement. So height and mass were separated by different colors. But if I change this fill to be species order, then right, I have humans and droids designated. And I started designating them as green and black up here. And so to actually add in those custom colors, I can add this new line where I want the fill to be species order, and now I'm assigning that species color. So now they're the custom colors that I've added in. And then here I wanted to show you, I don't want to keep you guys too long. I'm going overtime now. Does anyone have any questions related to that? Okay. So in the interest of time, I'm gonna, that's kind of a ways to go over the aesthetics. Separately, I'm gonna go back to like the simpler plots and show you how to put more than one plot into a single panel. So here we're the same base plot in both of these, where I have the box plots showing the height and mass, and then I have the bar plot showing the total number of species, droids and humans. And right now I'm just executing them so they appear in the plot window, but I can actually assign this. I was doing this earlier too, where I assigned this whole ggplot a value, and this I'll assign it a count. And then there's two different libraries to play with. I use both of these. I think I use CalPlot more, where they allow us to put more than one plot into a panel. And so it's really simple to use patchwork this way, where you literally just put a plus or a pipe in between them, and then you're now combining plots onto one panel. And you can assign that to its own value or our object as well, and you can start adding like annotations here. So it's like the annotations meaning, so sorry, this height and mass is instead of a plus sign or a bar, this slash, I'm actually adding the plot on top of each other, and I set that equal to another value, and then I started adding an annotation, and the annotations add my A and B value or panel label. Does that make sense? Everyone okay? Okay. And so the next thing I wanted to go over was the taxonomy bar plot. I keep calling it the taxonomy bar plot because I see it used a lot. I think I work with ASV and OT data a lot, and so that's something that's a really standard, like, first thing that you want to do when you get some of your data back is make those bar plots. And so I think this was my way of, again, reinforcing like why using the pivot longer or using a long format data makes it a little more straightforward to make those in ggplot. So this data set is already listed in, or already available in our studio. When I look at the ASV table, I have feature ID. This could also be an OTU ID. I have the taxonomy listed, and the taxonomy structure is actually, let's see, comma separated, and each level is just all pushed together. It's pretty standard for a taxonomy when you get taxonomy assigned. And then all the columns that follow are my different samples. and then the numbers equate to the sequence counts that belong to those ASVs or OTUs. And so, right, we can start kind of doing some of these basic things in base R to just look at what's available. I often need to do this call name just to make sure there's not any major errors. For instance, I just got a sequence data set back from a sequencing center, and they had switched. There was a typo, and there was like an I and an E in the wrong place in one of the names in just one spot. And so we're always like dealing with messy data, right? I'm just showing you these. I always have to check this to look for errors like that. And then this is again a very similar formula for how I showed you previously to change it to pivot longer. And in this case, I'm changing my ASV table where I'm again assigning those columns that I want to collapse down to longer. Those are all of my sample names. The values will be assigned to count. I'm going to remove all the, in that case, everything will be in a row. So I'm going to remove all the counts that are 0. And then another thing that I'm doing is actually these sample names, I'm actually going to separate into new columns where they'll be separated by this underscore. They're currently separated by an underscore, but I'll put them into new columns named accordingly. And I'm doing the same thing with the taxon IDs. So recall that this was the original ASV table where everything's kind of in this wide format. And then after doing this, we get, here, I'll actually do view here. We get a table that now still lists my feature ID, but now I have all of my taxonomy in separate bar plots. I know I have a lot of NAs. That has to do with what I study. That has nothing to do with R. Here's the taxonomy filled out here. And then if you go over to right here, right, I changed those columns to be in one sample. So all my sample names are listed here. They're separated out here, and then I have the count values. As you can see how when you start thinking about using grid in ggplot, I want to plot by like the event type or the year, for instance. And so having those in separate columns is really nice in this format. And then one thing I typically do is then taking that data and then summarizing it. Again, selecting, grouping by the supergroup that the taxonomy is assigned, the year, and the site. Removing NAs in the supergroup for now because they're just kind of irritating me. And then I'm selecting just 1 year for the purposes of showing you today. And then I'm going to sum all the counts that belong to the supergroups to each of the unique supergroup numbers. And so then I get this simplified table where I have my sample IDs, more information about where the samples come from, the supergroups I'm interested in, and the sums. And then I can use this ggplot, right, where I'm using geom bar in this case, stat is equal to identity, and I'm using position stack, which I'll show you what that does. I've already put in this 90-degree angle here, so you can actually see the sample names, and then you get this like that stacked bar plot. If you start moving position equals fill, this is when you can make the like relative abundance plots. And I urge you to also always think about how you interpret relative abundance when you look at these. Okay, so that's all of the code that I have for now. I know that we're up on time, but if you have any questions or are curious about one of the aesthetics that you can add to ggplot, Jacob, Philip, please add in anything that I missed or didn't go over. And also, we're going to continue showing a lot of these methods. And so if you have a question or want us to elaborate on one of these things, use office hours, go ahead and send it to the Slack channel. We'll make sure we get to it either in the Slack channel or in one of these sessions.